Section 11.7, Applications, Quadratic Equations. There's a few problems in this section where they'll give you some sort of fill in the blank type things. They're not really that difficult to do. They're pretty much just common sense kind of answers to these. Now, the first one, after an application problem has been solved, it is important to blank the solution with the problem in order to make sure the answer makes sense. In this case, check the solution to make sure that answer makes sense. That's usually with application problems. You know, if you've got the height of a tree, it shouldn't be negative. That's something that you'll want to just think about for a second when you look at your answers. Second option, or second question here, organizing the information in an application problem can be done through the use of a chart, blank, or diagram. Here you've got 4 different options. Table is the option that you'll want to go with. First step in solving an application problem is to blank the problem carefully at least twice. This one is read. And once an application problem has been read and understood, you should assign a or an blank to the unknown quantities. In this case, assign a variable. That's typically what we do with algebra. You take the unknown and you give it a variable. Number 1, the product of 2 consecutive integers is 72. Consecutive integers, these are, for an example, 5, 6, 7. Those would be consecutive integers. And they differ by 1. So from 5 to 6, you're just adding 1. From 6 to 7, you're adding 1. So here we've got 2 consecutive integers. We'll let the first be x and let the second equal x plus 1. Since with consecutive integers, the next one is just 1 more than the previous one. So we're saying the product of these two, so product means multiplication. So if we're multiplying x, since we don't know what the first one is, with the next one, which is just 1 more, we're going to multiply both of those, and the answer is 72. So the way that we'd write that is x times x plus 1, the product, multiplying those, equals 72. And then what you'll want to do after that is distribute x times x, x times 1. And then what you'll want to do is set equal to 0, and then we'll either factor or we'll use the quadratic formula. So set equal to 0, that means we're subtracting 72 to get it away from the right. Subtract 72 on both sides, and we've got x squared plus x minus 72 equals 0. And on all these, you can use the quadratic equation, or the quadratic formula rather, where your a would be whatever's in front of x squared, your b would be whatever's in front of x, and which is 1, and then your c would be negative 72. In this case, if you can factor, sometimes that's much easier, much quicker to get to the answer. This is a trinomial. You'd have 2 parentheses equal to 0, x and x in order to make the x squared. And then we need 2 things that multiply to be negative 72. 8 and 9 multiply to be negative 72. And in order to get them to add to be positive 1, we want the larger number to be positive and the smaller number to be negative. So negative 8 times 9, negative 72, and they also add to be positive 1. So this would mean that your answers are either positive 8 or negative 9. And in this case, negative 9. So you've got 2 different options. You can either do 8 and 9. These would be 2 consecutive integers. Or you could do negative 9 and negative 8, since we're adding 1. Be careful you don't put negative 10. But probably mostly you'll do 8 and 9 for your answers, but negative 9 and negative 8 would also work. Number 2, find two consecutive odd integers such that the sum of their squares is 802. So just for a second, consecutive odd integers. So hopefully everyone knows what an odd integer is. 5 is an odd integer, 3 is an odd integer. If we're talking about consecutive odd integers, if we're starting with 5, the next one would be 7. And in this case, these are separated by 2. So from 5 to the next odd integer, you add 2. If we were going from 7 to the next odd integer, we'd add another 2. So if we don't know what the first one is, we'll let the first equal x. And then we know the second one would need to be 2 higher. So x, and then we're adding 2. So that's the first one, and that's the second. But we're saying the sum of their squares is 802. So we're talking about the square of the first one, the square of the second one, and we're adding those. So x squared and the sum x plus 2 squared. So the sum of their squares is 802. So as long as you can come up with that, you'll want to square the parentheses. So x squared plus, this will be x plus 2 times x plus 2. And then FOIL that, x squared plus, so x times x times 2, 2 times x, 2 times 2. And then put your like terms together. We got x squared and x squared, 2x and 2x. And so 2x squared plus 4x plus 4. I'm going to go ahead and subtract this 802 equals 0. So subtracting the 802 gets rid of it from the right. And then we've got 2x squared plus 4x, and then plus 798, or actually minus 798. Equals 0. And one thing you can do here to make this a bit simpler is just to divide everything by 2. Then you're left with x squared plus 2x minus, what would that be, 399? Equals 0. And then you can try to factor that if you want. Maybe a quicker way to go, we'll do an example of the quadratic formula here. So the number in front of x squared would be your a, the number in front of x would be your b, and this last number here would be your c. So your quadratic formula equation, negative b plus or minus square root of b squared minus 4ac all over 2a. It might be a good idea to write that down on a sheet of paper so that you have that handy while you're going through this particular assignment. But b is going to be 2, a 1, and c is negative 399. So let's do this. Negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a, which is 1. Negative 2 plus or minus square root of 4 plus, let's see, 4 times 399, 1596, all over 2. Square root of 1600 is 40 over 2. And here we're just talking about consecutive odd integers, so these can be positive or negative. So here we've got negative 2 plus 40. Since they're like terms, we can go ahead and put those together, divided by 2. You can also do negative 2 minus 40 divided by 2. So negative 2 plus 40 is 38 over 2. Negative 2 minus 40, negative 42 over 2. So we get 19, and we also get negative 21. You can use either one of these, and we're talking about consecutive integers, so consecutive odd integers. So 19, the next odd integer would be 21. You could also do negative 21, and the next odd integer would be negative 19. So either one of those pairs, if you put those in, you should be fine. Number 3, the difference between two positive integers is 3. If the smaller is added to the square of the larger, the sum is 153. Find the integers. So this one, unlike the ones before, this doesn't say consecutive integers. They're just two random positive integers. So we'll let the first be x. And then we'll let the second, we're not going to say x plus 1 because these aren't consecutive. We don't know how they relate. So we'll just let the other one be y. And actually, let's let the y be the smaller one also. So when we go to put these back in, if we end up with x being 15 or something like that, that'll go in the larger one and y will go in the smaller box. So the difference is subtraction. Difference between two positive integers is 3. If the smaller is added to the square of the larger, the sum is 153. So the difference between the two, so x minus y is 3, and the smaller we said was y, added to the square of the larger, the sum is 153. So what we'll want to do going forward is since we've got two equations here, one from the first sentence, one from the second sentence, we'll want to get one of these variables by itself. In this case, I'll get x by itself. And the easiest way to do that is just to add y to both sides. So the y's cancel out there, and you end up with x equals 3 plus y. Then what we'll do is take what x is equal to, that 3 plus y, and we're going to plug that in for x. So y plus, instead of x, we've got 3 plus y. Actually, let's write this as y plus 3. It's a little more familiar. We're going to square that. So replacing x, since we know x is 3 plus y, square it, and then that's equal to 153. Going just a little bit further, y plus 3 times y plus 3 equals 153. Make sure you FOIL here, y times y times 3. 3 times y, 3 times 3. All right, so we've got y plus y squared plus 3y plus 3y plus 9 equals 153. So I'm going to put together our like terms. We've got 7 y's there in addition to the y squared plus 9. And ultimately, we'll want to set almost all of these equal to 0. So that 153, we're going to subtract that and then set that equal to 0. So from here, you can either factor it, if that's possible. You can try to factor it, or you can go ahead and label A, B, and C. A would be 1, B would be 7, and then C would be negative 144. You can put those into the quadratic formula. Here, though, I know that we can make negative 144 out of 9 and 16, and we want them to add to be positive 7, so you need the 16 to be positive, the 9 to be negative. And that means that we end up with two different answers. We end up with a positive 9, and we end up with a negative 16. But keep in mind, these are meant to be positive integers. So this one, the negative 16, is not positive, so these are supposed to be positive. So y is equal to 9, and then earlier we found out x was equal to y plus 3, or 3 plus y. So x is actually equal to 9, since we know y is 9. Plus 3, x is equal to 12. And make sure when you enter these in that the y is the smaller one. Number 5, a theater can seat 720 people. The number of rows is 6 less than the number of seats in each row. So how many rows of seats are there? So just to give an idea of how this type of thing is calculated, if you had, we'll say, 4 rows, and in every row you had 6 seats, to figure out the total number of seats, all you would do is take the number of rows times the number of seats to figure out the total number of seats. So if you take the rows times the seats per row, you get a total of amount of seats. So that's basically how we're going to set this up. We know that the total number of seats is 720. And we know that the number of rows is 6 less than the number of seats in each row. So we could just let the seats be S, and then the rows is 6 less than the seats. 6 less than the seats. And you might be tempted to write 6 minus S, 6 less than seats. 6 or less than is going to be subtraction, but you'll want to remember, this comes up every so often, this phrase less than, up here too, this phrase less than, it is subtraction, but it inverts the order. So instead of 6 minus S, we're going to do S minus 6. So here, instead of R times S, we're going to do S minus 6 instead of R, then times S. Distribute that S. We've got S squared minus 6S equals 720. Set equal to 0, which means we're going to subtract the 720. So again, you could do the quadratic formula A, B, and C, or if you know how this might factor, you can just do your 2 parentheses equal to 0. We know we'll have an S and an S. And if you go through the numbers, it turns out that 24 and 30 multiply to be 720. If you make the larger number negative and the 24 positive, then that's going to add to be negative 6. And so this will turn out S is equal to negative 24 and S is equal to 30. So if we're talking about S, that basically means seats. Not going to be able to have a number of seats that's negative. So our seats are going to be 30, and we're actually looking for the number of rows. How many rows? So the rows was 6 less. So basically all you've got to do is subtract 6 from the 30. So since S is actually 30, 30 minus 6, 24. Number 5, an orchard has 486 orange trees. The number of rows exceeds the number of trees per row by 9. This one basically gets set up the same way that we did the last one. The rows times the number of trees per row equals the total number of trees, 486. And here the number of rows exceeds the number of trees. So the rows are the same as the trees plus 9. The number of rows is actually 9 more than the number of trees per row. Okay, so that's the second step. Make sure you distribute the t. So t times both of those. So we've got t squared plus 9t. And I'm going to go ahead and subtract that 486 to set this equal to 0. And might be possible to factor this, but just for practice sake, we'll go ahead and do this with the quadratic formula, just in case you're more comfortable with that. Quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, just plugging those values in. And then negative 9 plus or minus 9 squared is 81. And then I'm going to have two negatives multiplying in there. So 4, 2144. Let me double check that. 1944. And then 2 times 1 on the bottom. Let's do this below. So we got negative 9 plus or minus 2025 all over 2. Negative 9 plus or minus square root of 2025 comes out to just 45 over 2. And going forward with this one, we'll just go ahead and ignore the minus part since we're talking about number of rows here. We're not going to have a negative number of rows, so we'll just go ahead and negative 9 plus 45 over 2. Okay, so we end up with 18. That's the number of trees. Since t was what we were solving for here in the equation. But ultimately we want the number of rows, or how many trees are there in each row? Actually 18. So we can go ahead and put 18 in for the answer on this one. Number 6, the base of a triangle exceeds the height by 6 centimeters. If the area is 260 square centimeters, find the length of the base and the height of the triangle. So up top, we've got the formula for area of a triangle. A equals 1/2 base times height. And a couple things that we're told about this. The base of the triangle exceeds the height by 6. So what we're going to do is we're going to replace B with exceeds. That means it's more than. More than is always addition. So it exceeds the height by 6. So basically you're adding 6 to whatever the height is. So what we're going to do is we're going to replace B with H plus 6. All the rest of it I'm going to leave the same. And then next, going to replace, we can replace area. They do tell us what area is. 260. So After that, one thing that you might do, so area is 260, is get rid of this 1/2, and the easiest way to do that is just to multiply 2. If you had 1/3, you'd multiply 3. If you had 1/4, you'd multiply 4. But we're going to multiply 2 on both sides. So the 1/2 and the 2 cancel each other out. And we're left with 520 on the left, 2 times 260. On the right, I'm going to go ahead and put the h out front since that's typically how we'll see this type of thing. But still, h plus 6 times h. And then just going to work this out from there. Going to distribute the h. And then also, I'll subtract this 520. So we've got this set equal to 0, which is typically what we'll do on these. Make sure you subtract 520 from both sides. So we've got 0 on the left. H times h is h squared. H times 6 is 6h. And then minus that 520. And then from there, you've got a couple different choices. You could do the quadratic formula. Hopefully you guys know A would be 1, the number in front of H, B would be 6, and then C would be negative 520. And then plug all that into the quadratic formula. That's one way to do it. If you can factor this, trinomials are going to factor into 2 parentheses. That's usually a little bit faster of a route. And then on this one, you want some things that multiply to be 520 and then add to be 6. If you run through the list of numbers, 520 divided by 20, 20 divided by whatever. But once you get to 520 divided by 20, you'll find that 20 and 26 multiply to make 520. Those are also 6 apart from each other, so you can make 6 out of them. You can get 6 from those two numbers. We want a positive 6, so we want the 26 to be positive and the 20 to be negative. And then from there, it should be pretty easy to work out what h is. H is equal to 20 and then also negative 26. So keep in mind, we are talking about length of the base and the height. Length and height are always positive, so this negative 26, that isn't a reasonable answer. So the height would be 20, and since the base is equal to the height plus 6, you just have to add 6 to whatever the height was, so you end up with 26. So the base is 26 and the height is 20. Number 7, a telephone pole has a wire attached to its top that is anchored to the ground. The distance from the bottom of the pole to the anchor point is 23 feet less than the height of the pole. If the wire is to be 2 feet longer than the height of the pole, what is the height of the pole? So we've got this height of the pole, which we're saying is x. The distance from the bottom of the pole to the anchor point. So we've got some kind of wire going down to some anchor point down here at the bottom. But from the bottom of the pole to the anchor point is 23 feet less than the height of the pole. So from the bottom to the anchor point, 23 feet less than the height of the pole. Less than, obviously going to be subtraction. Hopefully you guys are good enough with that. But when you have the phrase less than, not only is it going to be subtraction, but it reverses the order of the subtraction. So instead of 23 minus something, you're going to be subtracting 23 from the height of the pole. The height of the pole is x, so it's 23 less than x. And then we're told that the wire, which is the one going from the top down to this right corner, the wire is 2 feet longer than the height of the pole. Since the height of the pole is x, so 2 feet longer than the height. So the height plus 2. And once you've worked that out, then you just have to use the Pythagorean theorem, since this would be a right triangle. A squared plus b squared equals c squared. A and B don't matter so much, but make sure that this is your C. This is what's going to go on the other side of the equals. So basically, the way that you set this up, you've got a, which we'll go ahead and let be x be, square it, plus b, which we'll let the x minus 23 be. Make sure to square that. And then c, which is x plus 2, squared. So you want to square this side, and this side. And then make sure you've got your c on the right side of that. All right, once you've got that, then you're going to go ahead and solve this. X squared plus x minus 23 x minus 23 equals x plus 2 times x plus 2. Anytime you square it, you're just taking the parentheses times itself. So we've got x squared plus, we'll want to FOIL on both of those parentheses that are being squared. So we've got x squared. Ultimately, we're going to end up with negative 46x and then plus 529. And then on the right side, we've got x squared plus 4x plus 4 ultimately when you FOIL. Put your like terms together. No like terms on the right. Then you want to set this equal to 0. So that'll probably mean subtracting everything from the right. So minus x squared. Make sure you do that on both sides. Also minus 4x. Also minus 4. So everything gone from the right. Bring down the equals. We've got 0 over there now. X squared minus 50x plus 525. And you could do the quadratic formula. A would be 1, B would be negative 50, C would be 525. You're going to end up with some large numbers with that, but it should be fairly straightforward if you do that. If you want to try to factor this, I'll take a second and see if we can do that. X and X. Looks like 35 and 15 multiply to be 525, and we need them both to be negative if they're going to multiply to be positive. 525 and then negative 35 and negative 15 do add to be this negative 50 in the middle. So that means that x is equal to 35 and then also 15. So if we look back at some of the features of the word problem, both of these answers are positive. So if we're talking about the height of a pole, height could be 35 feet, could also be 15 feet. But if we look at this one here, the x plus minus 23, if you subtracted 23 from 35, that would actually be okay. You'd still be left with something that could be a length. But if you went ahead and kept this 15 minus 23 would actually end up being negative 8. So you'd be saying the distance from the bottom of the pole to the anchor point would be negative. Cannot be negative, so this 15 we're going to toss out because it does not work there. So 35 is the height of the pole, and that's all we're looking for on this problem.